dealing with all that for the last day and a half. So we're here to talk about a couple things. The first thing is safety. I just want to get a safety point across. So this is our entire gas system at a smaller scale, of course. 90% of the visuals that you see are based underground. So about 10% of this is all based above ground. So we'll go through the demonstrations, but before I get started, I want to introduce my team. First, I want to start from the top. Mr. Brian Clark is back there. That's my director from gas delivery. My name is Jimmy Orm. I'm the manager of gas construction and maintenance up in the northern sector of Delaware. Basically from the Christiana Bridge all the way up is our sector. From the Maryland border to the PA border to the river. With me I have Joe Rollo. He's one of my senior lead mechanics in construction and maintenance. Mark Piazza is a gas energy utility man, and Anthony Lewicki is one of my gas construction maintenance operators. So with that, the importance to us is when we see something, we say something. 811 is our biggest deal underground. Anytime we're digging, then we're going to get a hold of this utility. And with that, you know, we expect all the contractors and all the utilities to kind of be a part of that family, because we have utilities underground everywhere, all over Delaware, Maryland, the 5 states, Virginia, Washington, D.C. So we have underground utilities everywhere. Some are at medium pressures, some are at low pressures, and some are at elevated high pressures. We'll talk about the differences when we go through the demonstration and kind of let everybody know what we're dealing with in the gas business here. And this is set aside from electric. So I know when people talk about DelMarVa, they think right away electric. DelMarVa has a big piece of the puzzle in the gas delivery business also. So with that, I'm just going to, like I said, I'm going to stay away from this screen. Well, I'm going to talk about what we have and go through this in detail, not to bore you. We're going to try and hit every little thing, and then afterwards we'll let you kind of take a stroll around the display here and kind of do some hands-on and look and see what we have. Okay, so Joe, I'm going to turn it over to you, buddy.
So like Jim said, the trailer is showing you our gas system from when we buy the gas from outside the state, and it comes into a regulator station. A regulator station is basically like an electric substation. It takes the pressure from, we usually get it 170 psi up to 500 psi, and it runs through the regulator station and drops it down to 38 psi, which is the operating pressure for a normal residential area. And it just flows through basically all the way through the mains until you get to a service. Everything now is plastic. There's a lot of steel in the ground. There's a lot of cast iron. The wire goes with the service so that we can trace it out. We can find where everything is. Without the wire being plastic, you have no idea. We do have some plastic in the ground that didn't have wire, so that makes it kind of difficult to find where it is. The cast iron in the system, we're slowly getting rid of. We're at a point where I think we're like 5 years away from getting rid of all that. Some of that stuff is from like 1864, 1900, 1920, and it's primarily our low pressure, which is like half a pound. It's not the most reliable system, so we've slowly tried to get rid of that. Everything's kind of going more towards the high pressure. As far as above ground, normally this will be above ground, the regulator in the regulator station, and then the meter that you guys probably would be used to seeing and deal with the most. As far as everything else here, we have some demonstrations where we can demonstrate a low pressure versus high pressure. So this is the regulator that we use to drop it from 38 pounds to half a pound for residential use in a house. So you can see the difference between how much pressure comes out the end with it regulated versus if it was just straight 38 pounds. And we have another demonstration over here where this is called an excess flow valve. It's kind of like a safety check valve. So if somebody hits the line past that, it senses all that pressure and it trips. so that it won't just keep blowing. It'll pass a little bit so that you know that there's a leak, because we've had people that have trenched through the line, didn't know they hit it, but they smell a little bit of gas, or they didn't hear it when it first popped. So it'll pass a little bit so you can smell it. Kind of like just an extra safety feature that we probably started using about 10 years ago, and it goes on all services, unless it's a large commercial service, because sometimes it'll trip those out just by running in general. So we have that. We also have a burn stack. So if we have miles of pipe that we're retiring, say it's 12-inch and we have to retire 2 miles of pipe, all that gas that's inside of that pipe, we don't just let it into the atmosphere. So we burn it through the stack. It's the safest way to do it. So we have that as well.
So if you look at the picture up there on the screen, that's pretty much what it looks like when we burn off gas in the free air. So what that accomplishes is we're basically burning off the residual gas in the pipe, and then we're trying not to leave. We're trying to go down to zero balance in the pipeline so that we can safely work on it. And this is the way we're transitioning right now to different concepts where we have a machine called the Z-Vac machine, where we can take a machine, dump it in one, or take it out of one pipe, dump it in the other transmission line or distribution line, however, whatever pressures we're at, and we eliminate both burning off and any carbon seal or anything going into the free air or that contaminate, whatever environmental aspects. So that's what that does.
And then last we have, so that would simulate a piece of main with a 3/4-inch steel T going to a house, and if there was a leak on it, so they have pinholes. Those metal parts are clamps that we put on them to stop the leak. We have that simulation where you're going out for a gas leak, and it has a hole because it's deteriorated, what it would be like with that. Anything else?
Okay, so I just want to throw a scenario at you. Just last Friday, we called a Friday special at 2 o'clock in the afternoon when everybody's ready to take off. We had a contractor come in, put his bucket into an 8-inch gas main. Right here is only a 4-inch gas main, so now you can absolutely see the difference in the size. We only run at 35 pounds in the North District of DelMarVa. However, our sister companies, BG&E down in Baltimore, they run at 99 distribution pressure. So the amount of gas that's flowing out of there when something's damaged is so significant. It alerts everybody that there's something going on and something pretty bad. So you're going to get all the other emergency services responding, the police, the fire, the emergency response out of the state or county, and it becomes a big deal. So anyway, backing up, not to make a long story short, but that Friday we would have had to close 7 valves and lose a subdivision of about 80 houses, commercial combination. We try to avoid that at all costs, but sometimes we just can't. We were lucky to get in there and get on both sides safely, dig up other holes, and we have what's called squeezers. We can actually squeeze this plastic pipe. So we have special tooling that we can squeeze, isolate that segment of workspace, and then cut out whatever is damaged. So that's why I keep falling back on Miss Utility and all that to dig safe, because every time we have a leak or we have a damage, radar goes up. It takes a lot of assets to move out there and fix the problem. So with that, we'll go through the different scenarios here. Like Joe said, this is an excess flow valve. So if you have a service coming into your house, once the service comes into your house, we're going to stick this off what's called a T at the main. So we're going to tap the main. We're going to run a service. The crews are going to run a service. We're going to put that excess flow valve in it, because if that service is hit by accident, a lot of homeowners go out, plant flowers and plants, and nobody bothers calling. So you got your post hole digger, you're digging down, and you hit the plastic line. It doesn't take much. 1/2-inch plastic line will snap in an instant if you put enough pressure on it with a post hole digger and a sharp blade. what this does is it'll kick in. It's just like a check valve.
So usually this flow valve is here off the end of the T, like you said. If you were to hit it, you would hear that whoosh. This trips, stops the gas. Then when it's fixed, once the pressure builds back up, you'll hear this. This will re-click, and then you have gas pressure again. I don't know if you can hear it over the compressor.
So it'll equalize and reset itself. So we can just go in. So we kind of know when we pull up a service card in the office, we know that that valve is in place because the guys put it in 10 years ago. We have service records that show all that let us know, okay, it's broken, it's damaged, but it's more safe than it would be if we didn't have this flow valve, because it would be ripping out of that piece of plastic. Moving on to the next thing. This is the valves I talked about. We just had this cut open. By the way, I think it took us, how long did it take us to build this, Joe? About a year? Yeah. So it took us about a year to put this trailer together. We have an engineer back at the shop, Laszlo, we call him Laz. He took pieces and parts from each division in our company, and they went ahead and built this nice little display so everybody can get an idea what we do. So this is just a valve, a cutout of the valve. It's an actual full port valve. So, you know, our guys know that to read the operators, they know what direction it is, just clockwise close, counterclockwise open. And that's the valve I talked about, that we would have had to close 7 of them if we had an isolated area. And they're not as pretty as that on the ground, I can tell you that much. Most of them are slop. We have to sometimes blow them out, dig them up, and that's like the valve box behind it. That's what you see probably at your residence somewhere with the lid on it next to the water box somewhere. Okay? All right. Want to talk about anything else over here?
So the display for the pressure, like I said, this is the regulator that you would have on any residential, sometimes commercial, depending on the size. So you can see the difference between, right now, the pressure running through here is 1/2 pound. So you kind of see how slow it is. On the other end, this is where you just have the full 38. It's substantially different, especially if you go to a hit line. That's kind of what it's going to sound a little bit like that. Usually it's a lot louder.
Now
So,
the little one might work better for kind of what it would sound like glowing.
yeah. So it's kind of, we also have ones that go up to 2 pounds of pressure depending on what the customer needs. Sometimes commercial they need more like 2 pound system versus just the 1/2 pound. But the most common one is this. Unless you're already on the low pressure system, then you don't have to have anything like this. So the other one would be the
Yeah. So we talked about, you know, when we're isolating, we're working on a segment. It's a planned shutdown. So we're either doing a reinforcement, a replacement of old main, or we're cutting out larger type valves on a transmission system, which our transmission system runs between minimum 180 that will run transmission coming in. We call it over high pressure because actually transmission will run at 350 pounds usually. So we run around 180 in the DelMarVa Peninsula, the DelMarVa region. So once we do that, and we have bigger, what's called Bueller equipment that we're able to cut into the steel, and then we're able to stop it off with big, what we call wedge stoppers. They're pretty monstrous and they're pretty heavy. So we'll drop all that equipment into the shoring or the pit, and then we'll go ahead and stop off, and we're able to isolate our work area. Sometimes we have a run that we're getting rid of because we replaced 3,000 feet up to a mile of main, and we don't have that opportunity to stop off both sections. So we're going to stop off one, we're going to tie in the new stuff, and then we're going to bleed it down. And this is how we bleed it down. We put a perch stack on the very end of the run, usually somewhere around a regulator station or just outside of a regulator station. So go ahead and show them how this works. So this represents residual gas coming first. We're trying to pack the line because we're bringing actual natural gas. We wanted to get to at least 99% natural gas. So we're packing the line, we're pushing it, and over a mile long takes a little while, probably about 3-4 hours, because we're opening the valves very slow and we're just introducing gas into the system. So if you, this kind of represents, again, that picture that I had on the screen. Yep, it's on the screen, and the flames get pretty big because once we get to a higher pressure, we're going to open the valve fully open, and then this is kind of what it represents. At night it's pretty cool to see because it lights up the area. But it's our safe way to make sure that we have no oxygen or air in the system. We want to get all the air in the system, because if air gets into your house up through the regulator and the meter, it's going to knock out your pilots, and you're going to smell that gas coming in from the street. You're not going to know where it's coming from, and that's why we get the calls. Okay, so that kind of gives you a snapshot of what it looks like, what our systems look like. This is basically our intermediate system. Like I said, our higher elevated pressure systems are all steel. I don't believe we have too much plastic that are in high demand over our 35-pound threshold. So basically our operating pressures up north hover around 35 pounds. We do have 200-pound systems. We have some 450-pound systems coming across from the river. And we do have a lot of large diameter equipment and material that we work with. Other than plastic, we also work with a lot of steel and a lot of cast iron. So like Joe said, there was a lot of cast iron in the ground from the 1800s, early 1900s, and it's still in the ground, and we are in the process of getting rid of it with trying to get 8 miles of main a year, take that out of the ground and replace that with brand new polyurethane, so that we can get the system back up and running with minimal leak calls, odor calls, leak calls, and response calls, so we reduce that amount of problems in areas. So right now we're kind of concentrating on the Wilmington area and the surrounding subdivisions, and then later on we'll be branching out and starting to tackle some of the steel that we have in the ground that's a little bit older that we want to get rid of and replace that too with newer equipment. Okay? Any questions?
I got one.
Sure.
If Joe Hogarth in the back door in the front yard, put a gas line, can you trace that on the tracer wires?
Yeah, you want to talk about the tracer wire, Joe?
What's the standard for repairing that tracer wire? You just find it, wrap it together.
We just get what they call a bug. Any kind of electrical bug looks just like that.
Yeah.
We just bug it back together and then tape it. So if we break it or homeowner breaks it, you don't want to like twist it with like just a twist knot or anything like that. Yeah. Well, when we do it, we try to do it the proper way with the bug. I mean, there's people have actually twisted them together and taped them before. That will work. It doesn't hold up long term, but it will work if you break that. But normally we can actually tell where the break is too. So if you broke it and didn't know, if we go tracing it and it stops right there, we know you broke it. Or someone broke it, or they ran out and that's as far as it went. We can kind of trace it as far as right where it's broken or right where it ends. So sometimes, depending on installation, that could be, we could figure it out, just like, okay, you're 2 feet away from, say, the meter, or you're out in the street and now you're not getting it, and you lost it, you don't know where the main is. So it can kind of go both ways. But if you at least try to twist it back together, that would be helpful. But normally we can figure it out.
So the hook around tracer, something of that signal or something about the wire?
It's just a wire, and then we have a it's called a Metrotech. We clip onto it, and it'll trace it out the whole way, the whole length. So it's almost like kind of like a minesweeper, like if you were going out in the sand trying to look for coins or something. kind of similar to that, and it'll actually tell us exactly where it is. So if I go too far to the right, it'll actually tell me I need to go back farther to the left. So it'll tell me exactly where it is, and then it gives us a reading. If you're anywhere in the high 600s, 700s, you're right on that wire. So with the technology now, even if you break it, we can kind of tell that it's broken or whatever. But, yeah.
Yeah, so we don't have any equipment that can pick up plastic. I mean, there's just nothing out there. So that's the reason we run the tracer wire on everything. And you'll see the balls too, the yellow balls in different locations. Those are called ball markers. We have a special piece of equipment that'll actually detect those ball markers, and we usually drop those near critical spots, either on a fitting that we're joining pipe together, or a valve that's critical to us that we lose the box from. Just different types of things that we'll put those on.
Now, kind of going to your question, the transmission lines that we have, we actually induce a voltage onto those for corrosion reasons. So we induce a voltage on there to stop the corrosion and all the pipe breaking down. So we do that on the higher pressure stuff, the steel lines. It's called a no, for the transmission.
Oh, the rectifier.
The rectifier. Yeah, so we actually induce voltage onto those lines to help with corrosion. So that's a little helpful.
I thought the wires are tied together. The roads got there where you tie back together. You pick it up after that.
Yeah. Normally, even if it's corroded, it'll still pick it back up. The only other thing we didn't really talk about that I think is probably important, if you guys don't see, this gooseneck here, the yellow gooseneck. A lot of people don't know what that is. You'll see those at major road crossings, or sometimes you'll see them in the middle of nowhere. That just means that the pipe we have is going through another piece of pipe as a casing to protect it to go underneath the road or to go someplace it's really rocky. So if you see a gooseneck like that, there's a gas main somewhere around where you're at that's inserted into another piece of main as like a sleeve to protect it. And that's just, if that ever leaks, it'll leak out that gooseneck, so we can tell, okay, there's leaking somewhere around there. So if you, for a visual, if you ever see that gooseneck somewhere in the middle of a field or a road, there's a gas main there. Sometimes we don't bring that up enough to people to tell them what that actually is.
A vent for the case.
Yeah, basically a vent for the, it's exactly what it is. And then we inspect those, I think yearly, someone goes around and inspects them to make sure there's no leaks anywhere on them. So basically just.
Any other questions?
I got a question.
Sure.
From a safety aspect, why wouldn't you guys stay with metal lines rather than going with the PVC pipe? I mean, you're not going to break a metal line with a postal.
You actually are.
Sorry. Okay.
Not with a postal digger, but other equipment will. And
Is it because financially?
well, there's two reasons.
Yeah,
That's right.
yeah,
So
money.
there's a financial aspect of it, but I think the more important thing beyond that is that it takes a lot more resources to maintain the steel. Cast iron is gone. It's kind of, it's old school.
Right.
It takes a lot more resources to maintain the steel, welders, fabrication, repairs. So it's not.
You have to grease the valves.
It's not
Comes down to
manpower
maintenance and
smart.
money.
Yeah,
Pretty much.
yeah,
Exactly. Because
Yeah.
these valves, you just have to operate them yearly to make sure they work.
We do.
A steel one you
however,
have to grease.
Our larger diameter, more operating pressure.
You have to sleeve them, like you said.
They will be steel.
Oh, they will be steel.
They will be steel.
Okay.
Yep, they'll be fully welded and all steel.
Do you have check valves on them as well?
No.
No.
No, our check valves for those will be at substations and substation stations.
So like your 4-inch and your 8-inch plastic, you have those safety valves on those things too?
The check valve thing,
Yeah.
you mean? No.
Not on
No,
the boards?
they don't want to put them on mains just because the fluctuating of winter versus summer. So obviously you use more gas in the winter for heat, so then it starts calling for more, so they're always worried that it's going to trip one, and then you're going to have an outage because it tripped. So we've always, I think,
2 inches,
I think
2
it's-
inches the highest.
yeah, I think they've been doing that kind of standard throughout the gas industry. Nobody really puts the check valves in a main just for that reason.
But you said from 10 years ago you guys started putting them right
I think
in
it was
residential?
probably about 10 years.
Yeah.
So how much of your infrastructure do you have them on in the northern part of Delaware.
Quite a bit. Everything.
Have you gone back to the places that
Yeah.
were built before 10 years ago?
Yep.
And so
Yeah, that's part of our renewal projects that we're doing. Getting rid of the cast iron, putting in a new polyurethane. With that, every individual home will get a new service and an EFD check.
There's even times where the service is already plastic and maybe we're there because there's a leak, and we'll put one into a service that's already plastic just because we're there and we already dug it up. Let's just put it in because we need to put it in. Because ultimately it's just safer. You know, if somebody hits something, it's safer for us, and we pull up. So even if the service is already plastic, we'll put one in just because we're already there. Might as well put the safety feature in just because
you
we're
guys
there.
have initiatives where you get to areas and just replace all that stuff?
Yeah.
Yeah, we're doing that. Yeah, we've been doing that now for the past, how many years, Brian? 12 years.
Really?
Well, we just focused on the areas that had the most leaks, which was the city where the cast iron low pressure was. We either had a lot of leaks, or we had a lot of water intrusion. So once the water intrusion goes into low pressure, people lose gas, or it freezes up in the winter.
And that's a good point that Joe makes, because that's another incident that we just had. You know, we had the horrible floods going on across the Northeast lately. The Brandywine got hit up there, and we got slammed. We lost a district in the northeast village of Wilmington. So it was about 124 homes that were affected from that. So because we did the replacement years ago with the polyurethane, we had no water intrusion in our main. After we shut it down, we bled it all out. So we were very lucky, so that we know that this system will stand up to a lot of stuff. Besides a backhoe, won't stand up to a backhoe.
That doesn't work too well.
I had a question about that Friday special. They hit that 8-inch main, and then the whole time it was just blowing.
Yeah, it blew for about 50 minutes.
50 minutes. So did you guys call in emergency tickets to dig down to then go squeeze the pipe? Is that what?
Emergencies are automatically called once a damage is.
No, I meant like the misutility ticket, the emergency
That's what I'm
misutility
saying.
ticket.
It's
Yeah.
once we hear that a damage is done, it's automatically called.
Okay.
So,
how
so
how
we're
far
all-
away from that break
We
did you guys dig?
usually go 100 feet in each direction.
Okay.
You know, just to cover our boundary.
Gotcha.
And we have internal locators too that can kind of get there in an instant.
Nice.
You know, and we do contract some of the locating out, but most of our internals will react to those.
He literally squeezed the pipe.
Yes,
Yeah.
we have big,
Yep.
gigantic squeezers.
We have them all
It's
different
exactly
sizes.
what
We
it
can
looks like. It's a
squeeze-
steel piece on top and bottom.
We can squeeze
and,
half-inch all the way up to 8.
We both have both hydraulic ones and manual ones.
Like so, half-inch, 1-inch, half-inch to 6-inch we can do by hand. You can do the 6 and 8 by hand, but it's not fun. So we have hydraulic ones that you really just pump. And as you pump, they just squeeze it down.
Once you guys did it, then you got to replace those spots to squeeze, right?
No, they're
Don't bounce right back.
no, they're marked, but they're not replaced. They're marked because you can't squeeze in the same place twice. That's
we
the
mark
whole
them.
idea.
We just
so
tape
you
the
get
main.
one shot, one time.
How far away from the next time?
It's 3 times the diameter of the. Am I right?
Yeah.
3 times diameter of the pipe is how far we need to squeeze.
It looks kind of sketchy, to be honest with you. You know, when you first start doing it, you're like, is this okay? Because sometimes it just looks like the side's going to blow out, but everything's good. It lasts. I can't remember ever going back to a squeeze that actually.
And the cold weather doesn't affect the squeeze.
It does. You have to go slower. You're supposed to like take more breaks, go slower. We have some older pink plastic. It's from DuPont plastic. It's not the best. That's really sketchy because that will crack in the side. So you have to go even slower with that.
Yeah, I've got
So
to see that.
It does. You do have to go a little slower when it's cold out. I'm not saying there's times where you don't feel like it's a little crazy that you're doing it, but it comes back. It bounces back. Like I said, I haven't been back on any of them that have actually broke free later on and we had to fix them. But we do mark them so you can't go there again. We just kind of tape it. But
It's got to be safer than wild.
I mean, really, the squeezer just saves you from more major outages. Because if you had to shut valves off, we could squeeze and only kill 2 houses. We shut a valve off, it's 200 or it's 50, or so it's more of just trying to mitigate that. You can't keep putting more valves in, because then that's all valves you have to maintain. So it's like a balance of where you go. So the squeezer kind of helps out.
How do you guys work with municipalities and state to repair the roads after you're dug them up?
Depends on the municipality.
Yeah, most times we need, I mean, probably with everybody needs, we need the permits. You know, our normal operational work, we will go through the operational tempo the same as any other utility. There's utility tickets, road closures, drawings from engineering, procedures from engineering. Any job that's planned will go through pretty much the same aspect as any other utility or contractor.
Normally, once the job comes to me as a leader, depending on where you're at, the paperwork will say this municipality wants it backfilled like this, or they want it like this, you know. And then once it goes to the restoration part, that's out of our hands. We have contractors that do the restoration, because like the city of Newark is very picky about how they want it. They're a little different than the city of Wilmington. City of Newark is like specific. The guy comes out and watches. They want it done certain way, which is fine. But
yeah, there's some want setbacks. Some we have an actual agreement that will do the whole road. You know, it depends how long we've been in the area, what we're doing, and what the where the costs are going to. You know, so it's more of part of a business aspect. It's more of getting. The customers are the biggest thing, you know, because a customer sees a patch in their street and it just got repaved 5 years ago. You know, we want to get on that and get it restored. So,
when you guys have a blow up like that, what do you have to do as a safety aspect to make sure somebody doesn't come walk through your store with like cigarette? I mean, how flammable is it? You know, how dangerous is that? Is there a procedure you guys go through? You got to shut down half a mile, nobody within this half a mile, or something like that?
well, if we're going to do some kind of burning,
I mean, if you had a break like that, like somebody dug it up.
okay. So we normally cone everything off. We make sure everybody's away. I mean, we try to. For us, it's like you can't get in the zone of the gas without FR on within 6 to 10 feet. So we try to at least keep people back 15, 20 feet away from where we're at. Because once you get closer to that, once you get within 10 feet of the actual hit, you got to have full FR on and our whole PPE process. So we like to push people at least 20 feet away. A lot of people think the cigarette with it blowing will light it on fire. I mean, I have never seen that. I don't think that's the case. There's a perfect mixture you got to have of oxygen and fuel and all that. That really won't happen. But it's kind of good that people think that. So we usually don't give the information to say, hey, no, that's not a good
Has anybody tested that theory?
Yes. Yeah. Old school crew leaders like one of these lighter in the hole. To be honest, yes. That has been tested. You're like, oh, they're alive. But yeah, that's the old stuff. So yeah, we usually try to keep them back to 15. It's just literally cones. Sometimes you could, if it's in the street, you park the truck a certain way.
We're pretty reactive to these. I mean, you know, it's kind of like we're Mercy Service too. So if something like a half-inch line gets hit or a 1-inch line gets hit from a homeowner, we're pretty much hoping that, you know, we've already tackled the EFE issue. But if it's anything larger, you know, the first ones that are usually getting called are the fire department. The homeowner or the contractor will reach out to the fire department, and that kind of hits all of us at that point. We have a specific call center that calls us through dispatch and lets us know what's going on. They don't have the specifics. We're in charge of getting the specifics for everything, so we kind of know by all of our historicals what we have in the ground in that area, and it kind of, you know, funnels into what kind of manpower we need to fix that. But we're pretty reactive to that. So, but you know, like I said, you have all kind of entities within the region that respond to that. Police shut blocks down. You know, fire department get in there, hoses ready. So it's pretty secure by the time, if not by the time we get there, close to the time that we get there. So.
I mean, we've had times where it was blowing and we've had firemen with hoses in their hand just in case, because it was, you know, a situation that was a little crazy. We didn't have a way to really control it any other way than get in there. So we've had times where that's happened before. Like you said, I think because we're so small, we're not as big as Pico and BG&E and our other companies. makes us a little more agile. You know, we're quicker to things. We can respond to things. We come together as a group a little faster between engineering. Who do we call? Who we need? It's a main. It's this. It's that. We tend to operate a little more like, I like to call it Navy SEALs. Like we're very like in and out quick, where Pico and BG&E are so big. It's like turning a tank or turning a, you know, it's like turning a ship. It just kind of takes a little longer.
Well, the difference is too is that we have one operating gas facility, so we're kind of all like one big happy family in one big building. Whereas our sister companies may have 5 different, you know, locations in their territory, so it might take a little longer for them to get the word where it's at. But they build that rapport too in those areas, you know. So it's kind of the same way. We build a rapport too with our communities, as far as getting to know the inspectors, getting to know who the Public Service Commission guys are, all the way down to the customers that, you know, may be repetitive customers that, you know, are calling in the same odor the next day. That, well, wait a minute, we just had a crew out there. Let's go see what's going on. So we try to establish a good rapport with both the community and the surrounding municipalities. Definitely.
What would be your advice if I had a crew out and they were operating a backhoe and they did strike a 2 or 4 inch line?
I would say call Miss Utility first.
I mean, because my advice is shut the machine off and haul ass. So is that, you know, after the cigarette thing, I mean...
No, that's good advice. We would definitely want you to shut it down and just get, you know, back off from the area. We don't need you to take the bucket out and back off and keep the machine running.
We've had
Just
contractors.
shut it. I've seen. Let me be honest. I've seen explosions where a fire truck pulled up and there was a gas leak on a 99-pound steel main over a bridge, and that fire truck went up. The exhaust from that fire truck, or something on the bottom of that fire truck, ignited that source, and we bought that whole bridge. So it wasn't a pretty sight. So it does happen. I would say that's my best suggestion, you know, to your guys, is to shut it down. You know, walk away and let us take care of the rest.
Sometimes they shut it down and just move 50 feet down and continue to work.
What's that?
Sometimes they shut it down, they move 50 feet away and continue to work while it's blowing. That's not helpful either. You know, we try to tell them just shut it down and get out of the way, completely out of the way. I mean, time is money, I understand. You know,
I could say, if, you know, for you guys to be, I say you guys, anybody to be in the right thing to do, call the Miss Utility, wait till that call clears, get out there and do what you have to do. But your leads, your supervisors, your senior workers out there, they just need to be cognizant of their surroundings, right? I think we're all, as leaders, we know that, that we need to go out, we need to look around. You see wires overhead, you kind of suspect there's no wires on the ground. We got gas everywhere, you know, and like I said, we cut off at the Chesapeake, so everything south here belongs to Chesapeake. So it's pretty much almost the same system, different company, you know. But same thing in Maryland, same thing in DC and up north in PA. So, you know, that's my advice, is make sure you call 811, get the marks you need. And then if you realize that there's something in the ground because there's a telephone box there, or there's a cable box there, and it's not marked, then it's up to you guys to call back and say, you know, where are my marks at? You got to get me marks here. Or if they just start digging, you did your due diligence to do it, but you got to start breaking out the shovels and hand dig, right, to expose those facilities.
Do you guys have
Pain in the rear, but that's what you got to do.
I usually call most of the utilities for when we do work. We dig in the ground a lot. I find out to call Miss Utility if we have a hit or something is not the way to go. They usually tell me you need to call DelMarVa Power. You guys have a line, it's got a hit line. Call that line. You usually get a woman. She goes, okay, where you at? Okay, let me get a hold of John. And John, call you. I mean, is there a direct line?
Oh, I'm not talking after.
You mean like after the hit?
Yeah, I'm talking about after.
Yeah.
Oh, no.
Yeah.
After it's too late.
Normally for
that's
us,
what I'm trying to find.
we actually
What's
have an
the
actual number.
So the best route to get to you guys after that happens.
So you're saying you haven't called a Miss Utility? I don't
Oh,
understand.
no. I call these utility tickets.
But you hit something.
We get the marks out there.
Okay.
Sometimes the marks are.
Yeah, we agree.
Yeah.
It's like that for us too.
Let's just be honest.
It's like that for us too.
Yeah. We try to be pretty diligent in what we do.
Well,
If you guys tell us to hand dig, we're hand digging.
Yeah.
Yeah, we do that, but we've hit stuff. And they say call Miss Utility. First thing Miss Utility tells you is call DelMarVa. So you go on your.
Where are you located at?
We're right up right by. Kind of take care of the Bear, Newcastle, Middletown area.
Yeah, so you should be calling our call center. So you can see me after. I'll make sure you have the call center. They go directly to dispatch, which comes.
It'll go directly to dispatch. Yeah, I've been ran around for an hour or two.
Yeah, you don't call Miss Utility when you hit something and it's ripping or you got electric or something here. Now you got to call our call center.
And we run hit lines every single day.
What's that?
We run hit lines every day. As much as we go out there and we talk about it, and there's other departments that talk about it with contractors, and we draw contractors in, we run hit lines every single day. Every day somebody's hitting it.
And that call center is good for electric as well?
Yes.
Yes.
Call center is electric and gas. Ours is, yes. Yes. So if you're in our territory, please see me after. I'll make sure you have the number. I'll even give you my card. You hit something, you can call us. But the routing is call center that'll get to us through dispatch. Because we have to send Mark Bialis a emergency responder. So we have guys in vans that are going out. They're like the scouts for us. So they go out, their eyes on it. So they can report back and say, Jim, we got an 8-inch hit main. Or Joe, we got an 8-inch hit main. We know the group to get together to send them out in the big trucks and go start taking care of it.
Now, when that call goes into your call center, do you guys take it from there with the 911 dispatchers for the emergency response part, or after we make that call to you, should we call the 911 also?
The 911 emergency call?
Yeah.
Our system through the call center will only route to us.
Okay.
So 911 is definitely, the alternative route depending on your situation.
But I mean, if we call the number you're going to give us,
That's
do
just
you guys
strictly
know,
our.
then we need to still in turn
If
call.
you feel like that's necessary,
Yeah.
I mean, if it's like if you
Well,
hit a main,
it's where we are at CYA.
then you're fine. Yeah. Sometimes as a crew pulling up, it's great to have the firemen there because they kind of move everybody out of the way. Sometimes they get in the way, so they've been better with just getting out of the way, but kind of getting everybody else out of the way too. Sometimes it is kind of nice to have them, because then that's one less thing you've got to worry about. Especially as a crew leader, you can just focus on the job, and firemen move everybody out of the way. So it is kind of nice to have that.
Because I'm thinking of the notification aspect for the residents and all that. I'm not sure how that works because obviously we don't do that part of it. So I didn't know how that flowed, but it sounds like that wouldn't be part of what you guys do. You get the information, you go out for the hit only.
Yep.
And we actually relay the customers.
911 first, then us.
Any other questions?
Yeah, I'm gonna move these guys down to the next one, but will you guys be available for
absolutely.
questions for a little
Yep,
while
yep.
and stuff? So, we can do a
Trying to tell me I
little
talk
bit of
too much.
multitasking. Yeah, you're good. It's great. So thank you so much for this stuff. But so we're gonna move down. Unique's gonna start a demonstration, but these guys will be here, and, you can hit them up with some questions as well. So
Thanks, everybody.
yeah, thank you so much.
Thank you.
Yeah, right.